we are moving on to the problem. The first question is analyze the continuous beam given in figure. So here the beam is having two continuous spans AB and BC, and first is an eccentric loading and second one is a center loading. So the first step for free moment equation is to draw a free moment diagram. So for an eccentric loading, the free moment diagram is a triangle, and also for center loading, the free moment diagram is a triangle as already explained. Here the maximum minimum value is WAB by L, and here it is WL by 4. Here the equation for substituting it would be 10 into 2 into 4 divided by 6. Here it would be 10 into 6 divided by 4. After drawing the free moment diagram and finding out the maximum minimum value, we need to write the equation of free moment equation. So as already explained, two consecutive spans are taken at that moment. So here only two consecutive spans are there. So we are considering AB and BC. Now we need to write the equation. The equation is MA into L1. Since the moment of inertia value is same, so the equation will be MA into L1 plus 2MB L1 plus L2 plus MC into L2 is equal to minus 6 A1 divided by L1 minus A2 divided by L2. So since the free supports A and C are simple supports, so the moment value of MA and MC would be 0, and as the support B is acting as an intermediate support, so it would be, though it is a simple support, it would be acting as a fixed support since it is intact by the two members BC and AB on both sides. So MB value would be there and MA and MC would be 0, as A and B are the free end supports and also they are simple supports. So these two terms will vanish since MA and MC are 0. Only this term would be remaining at the left hand side, that is 2MB into L1 is 6 plus L2 is also 6. Now in order to solve the right hand side, we need the parameters capital A1, small a1, capital A2 and small a2. So capital A1 is the area of the free moment diagram for the first span, that is the area of this triangle. We know that the area of triangle is half PH. Then we need to calculate this value, and the apex value is obtained as 13.33 and here it is obtained as 15. So we are having half into base is span, which is equal to 6, and the apex value height is 13.33. Similarly, capital A2 is equal to half into B value 6 into H 15. Now small a1 and a2. Small a1 is the center of gravity from free support of this diagram, and small a2 is the center of gravity of this figure from the free support. So for an eccentric loading, the equation is L plus A by 3, where L is the total span and A is the distance of load from the free support, which is equal to 2. So here the equation would be 6 plus 2 by 3, and for center loading the equation is L by 2, that is 6 by 2. So after finding these values, capital A1 and capital A2, small a1 and small a2, we need to substitute these values in the right hand side. So here the equation would be minus 6 into capital A1. Capital A1 here it is obtained as 40 into small a1 2.66 divided by L1 which is equal to 6 minus 6 into capital A2. The capital A2 value is 45 and small a2 is 3 divided by 6. So solving these equations, we would be getting the value of MB is equal to minus 10.07 kilo Newton meter. So after obtaining the MB value, we need to write the final fixed end moment, that is MA is equal to 0, MB is equal to minus 10.07 and MC is equal to 0. After obtaining the moment values, we need to draw bending moment diagram. So for drawing the bending moment diagram, first we need to draw the free moment diagram as itself. The free moment diagram values are 13.33 and 15. Now along with this free moment diagram, we need to mark the fixed end values. So we know MA is 0 and MC is 0 and MB is minus 10.07. All the moment values should be marked in a single direction, either on upside or downward. So here we are adopting above the beam. So if you mark minus 10.07 ആയതുകൊണ്ട് ഇവിടെയല്ല, ഇവിടെ തന്നെ മാർക്ക് ചെയ്താൽ മതി. 13.33 15 താഴെ. So we are marking that value. Now we are joining the fixed and moment values 0 to 10.07, then 10.07 to 0. And for completing the bending moment diagram, we need to shade the uncommon area. Not common, it's uncommon area. So these are the uncommon areas for both the diagrams, fixed end moment diagram and free end moment diagram. So here it is a positive area, here it is a negative area, and here it is a positive area. This is the BMD. In problem, it is also asked to find out shear force value or shear force diagram. So to find shear force, in order to find shear force, we need to split the beams given. So here these two beams, beam AB and beam BC. Beam AB consists of 10 kilonewton, 2 meter, 4 meter. Here it is 10 kilonewton, 3 meter and 3 meter. So for finding the shear force value, first we need to split the beams as shown. Each beam should be splitted as shown. Then the reaction values are calculated corresponding to the loading given. So for an eccentric loading, the reaction value, as already said, is here WB by L and here WA by L. So substituting the value, it would be 10 into B is 4 divided by 6 and here it is 10 into Q by 6. Along with this reaction, we are adding the reaction due to unbalanced moment. So for MA, the value is 0 and for MB, the value is minus 10.07. While marking the moment, the hogging and sagging moment should be considered and the direction should be marked. Then here both the direction for reaction would not be in the upward direction. So we need to note that here the beam is, while application of this moment, the beam is moving in an upward direction. So a reaction in the upward direction should be given so that an anti-clockwise moment would be acting and the beam would be in a straight position. In that way, the sign of the reaction is marked. അതർവൈസ് നിങ്ങൾക്ക് പെട്ടെന്ന് ഓർക്കാൻ പറ്റുന്നത് എവിടെയാണോ മൊമെന്റ് വാല്യൂ കൂടുതൽ സൈൻ കൺസിഡർ ചെയ്യാതെ എവിടെയാണോ മൊമെന്റ് വാല്യൂ കൂടുതലായിട്ട് നിൽക്കുന്നത് അവിടെ വരുന്ന റിയാക്ഷൻ നിങ്ങൾ മുകളിലോട്ട് മാർക്ക് ചെയ്യുക. സോ ഹിയർ ഇറ്റ് ഈസ് മാർക്ക്ഡ് വിത്ത് അബോവ് ഡയറക്ഷൻ. Then here it will be downward direction. Then these reactions are founded by the equation R is equal to unbalanced moment divided by L. That is difference between the moments on the two supports divided by L. Here it would be 10.07 minus 0 divided by 6. So the reaction is obtained as 1.67. So here it is in the upward direction 1.67, here it is in the downward direction 1.67, and here it is 6.67, and here the value is obtained as 3.33. So on adding these two, we would be getting the final reaction at A and B. So here the final reaction would be, here it is positive 6.67 minus 1.67. So what would be the value? 6.67 minus 1.67, which is positive 5. And here it would be 3.33 plus 1.67, which is also equal to 5. So we are getting the value of RA is equal to 5 and RB is equal to 5. Similarly, in the same manner, find out the reactions for RB and RC corresponding to beam BC. So for beam BC, the equation here, we are obtaining the reaction as 5 and 5. You can solve it by using the equation. I am just writing it here. Plus the value due to unbalanced moment. So here the MC value is 0 and here it is 10.07. Here also the theta moment value is 10.07. So here the reaction would be in upward direction 1.67. Here it would be in downward direction 1.67 is equal to total moment value would be, here the value is 5 plus 6.67, which is equal to 6.67, and here it is 5 minus 1.67, which is equal to 3.33. So now we have obtained the values for RA, RB1. So the RA value is 5 kilonewton, RB1 is 5, RB2 is 6.67 kilonewton, RC is 3.33. So the final RB would be the summation of these two. So now the reaction values are obtained. RA is equal to 5 kilonewton. RB is equal to therefore 11.67, 5 plus 6.67, and RC is equal to 3.33. So after obtaining the reaction values, we need to draw the shear force diagram. So in order to draw the shear force diagram, first you need to draw the beam given in question as such. Then we need to draw just a line diagram for the beam. So here the RA is obtained as positive 5. So it would be above the beam diagram. So up to here we have marked 5. Then up to 10 there is no loading, so there will be a straight line. Then it is in the downward direction, so positive 5 minus 10, which is equal to minus 5. Then up to B support there is no value. Then in B it is 11.67, positive value, so plus 11.67. It would be here somewhat 6.67. Then up to 10 no value. Then minus 10 it would be minus 3.33. Here also the reaction is 3.33. So up to C it is 3.33, then plus 3.33 it is 0. So it would be plus minus plus minus. അപ്പോൾ ഈസി വേയിൽ പറയാം, നിങ്ങൾക്ക് ഷിയർ ഫോഴ്സ് ഡയഗ്രാം വരയ്ക്കാൻ കാൽക്കുലേറ്റർ കയ്യിൽ കൊടുക്കുക. ഇപ്പോൾ ഈ ബീമിൻ്റെ ലൈൻ വരച്ച് കഴിഞ്ഞിട്ട് കാൽക്കുലേറ്റർ കയ്യിൽ കൊടുക്കുക. കാൽക്കുലേറ്ററിൽ ഫസ്റ്റ് നമ്മൾ ആറയുടെ വാല്യൂ പോസിറ്റീവ് 5 അടിച്ചു. അപ്പം കാൽക്കുലേറ്ററിൽ അടിച്ചു പോകും. ഞാൻ പറയുന്നതിൻ്റെ കൂട്ടത്തിൽ നിങ്ങൾ അടിച്ചു പോയി കൊടുക്കുക. 5 ഇവിടെ വരെ ലോഡൊന്നുമില്ല, സ്ട്രെയിറ്റ് ലൈൻ വരച്ചു. ആ 5 മൈനസ് ഉടനെ തന്നെ കാൽക്കുലേറ്ററിൽ 10 അടിക്കും. ഇവിടെ വരെ വന്നിട്ട് 10. അപ്പോൾ താഴോട്ട് വരുമ്പോഴേക്കും എന്തായിരിക്കും? -5 വരുന്നത്. 5 minus 10 would be equal to -5. ഇനി അടുത്ത സപ്പോർട്ട് വരെ വേറെ ഒരു ലോഡ് ഇല്ലാത്തതുകൊണ്ട് സ്ട്രെയിറ്റ് ആയി. ഇനി ആ കാൽക്കുലേറ്റർ കാണുന്ന -5ന്റെ കൂടെ തന്നെ കാൽക്കുലേറ്റർ എടുത്ത് വെച്ച് സ്റ്റോപ്പ് ചെയ്ത് ഒരേ ഇക്വേഷൻ പോലെ അടിച്ചു പോകേണ്ടത്. അപ്പം -5 പ്ലസ് 11.67 കൂടെ അടിച്ചു. അപ്പോൾ എന്ത് വരും? പോസിറ്റീവ് 6.67. നിങ്ങൾ കൂടെ അടിച്ച് പോയി നോക്കുക. എന്നിട്ട് ഇവിടെ വരെ വന്നു. നെക്സ്റ്റ് -10 ചെയ്യുമ്പോഴേക്കും -3.33 വന്നു. പിന്നെ ഇവിടെ വരെ ഒന്നുമില്ല. പിന്നെ ലാസ്റ്റ് ഏതാ? പോസിറ്റീവ് 3.33. അപ്പോൾ നമ്മുടെ 0യിൽ വന്ന് ക്ലോസ് ചെയ്യും. അപ്പോൾ കറക്റ്റാണ് നമ്മൾ കിട്ടിയിരുന്ന റിയാക്ഷൻസ്, അല്ലെങ്കിൽ നമ്മൾ ചെയ്തിരിക്കുന്ന പ്രോബ്ലം കറക്റ്റ് ആണെങ്കിൽ ഇത് നമുക്ക് ക്ലോസ് ചെയ്യും. And this is the shear force delta. So like this we are doing the problem for free moment equation. Okay, thank you.